Hello student. Today we're gonna discuss about these polymers. I think this the unit polymer, which is new unit for you. The reason why because as far as I know, in your grade 7 up to grade 11 chemistry, you don't have such unit, okay? But you are familiar with this unit in your biology lesson about these carbohydrate, polysaccharides, amino acids, like that, okay? Now let's dive to this polymer. The first thing, what we're gonna do here is that we should to define the term as itself, okay? Here it says polymers. Poly, poly, meaning many, it means that, okay? Many part. What about here monomer? Monomer, non-linked single units of material it is. So when you unite these monomers, large number of monomers, you will get polymers. So how do you define polymerization? Is that here a long continuous chain of molecules formed from a repeated sequence of small organic units. Molecules, molecular weight in excess of thousands is considered to be as a polymer. So after knowing this monomer, a single unit, or which is a building blocks of polymer, and polymer, a large molecule made up of monomer, again, we need to define this the term polymerization. How do you define this? Polymerization is that polymerization is the process of formation of polymers. The process of formation of polymer. In order to form these polymers, we use heat, pressure, or chemical catalyst to link monomer materials into polymer chain. The repeating unit or the building blocks of a large molecule, what we call polymer, is monomer. Monomer is a starting unit or a building blocks of polymer. Now let's start here by revising all the concepts of polymer with related to biology by using a little bit funny song.
The body synthesizes four kinds of polymers by condensing simple molecules called monomers. Polysaccharides, polypeptides, triglycerides, and don't forget polynucleotides. Saccharides are sugars, and the liver's fond of joining them together with glycosidic bonds. Polysaccharides, polypeptides, triglycerides, and don't forget polynucleotides. Polypeptides are proteins manufactured from amino acids joined together with peptide bonds. Fatty acids react with glycerol, forming triglycerides which are insoluble. Polysaccharides, polypeptides, triglycerides, and don't forget polynucleotides. Polymers that we know as polynucleotides have a sugar phosphate backbone with bases off to the side. Polysaccharides, polypeptides, triglycerides, and don't forget polynucleotides.
Wow, I think the song remind you what you have learned in your biology course, especially grade 11 biology. Am I right? Okay, let's proceed now. The next thing, after knowing these definitions of polymer and monomer and how polymerization takes place, our lesson will be here now, classification of polymer. The first parameter which is used to classify a polymer is the first our technique which is used to classify polymers by based on their source. Based on source, polymers can be classified into how many parts? Three. Here you have natural polymer, semi-synthetic polymer, and synthetic polymer you have, okay? What the difference between this natural and synthetic is that synthetic is man-made, whereas natural, which is found in nature. What about this, the middle one, semi-synthetic, is that it is the combination of man-made and synthetic material. Now let's see what are examples of these natural polymers. Protein, cellulose, starch are considered to be as a natural polymer. What about here now, semi-synthetic polymer? Cellulose nitrate, cellulose acetate are an examples of these semi-synthetic polymers. What about the synthetic one? I mean that purely man-made of plastics, nylon, and bone is considered to be as a synthetic polymer based on the classification of source. Now let's see here again the classification of polymers based on the type of monomer we use. The first one, homopolymer you have, okay? Homopolymer, homopolymers are those made from only one type of monomer. For example, here polyethylene. Polyethylene is a polymer which is made from a single unit what we call ethene. When large molecule of ethene combine together by this addition polymerization, they form polyethylene. The next type of polymer here, what do you have? Copolymer. So how this copolymer different from homopolymer is that in case of copolymer, there should be more than one type of monomer. For example, here you have ethene, again here you have propene. When you combine a monomer unit of what we call ethene with that of propene, in the presence of catalyst, copolymer is formed. Next, you have again subclassification between these copolymer. Why? Because copolymers are polymers made from two and more than two things. Due to this reason, their arrangement matters. So the first one here is that random copolymer. In random copolymer, our repeating unit is arranged in random manner. Here A you have, here B you have, here A. So it's random fashion. If our repeating unit arranged in random fashion, we can call it random copolymer. Opposite of this random copolymer is regular copolymer. Regular polymers are those polymers which have regular arrangement of these repeating units. Next, here you have again another classification of polymer based on what? Their structure, okay? Based on structure, we can classify polymers into here linear polymer you have, here branched polymer you have, here cross-linked or network polymer you have, okay? So, what are examples of these linear polymers? Polymers of long chain. Example, high density polyethylene, polyvinyl chloride are considered to be as linear polymer, whereas the branched one, which includes low density polyethylene, cross-linked, example, bakelite, melamine is considered to be as this cross-linked polymer. Next, again, you have another classification parameter. What is that? Based on molecular forces, okay? Based on these molecular forces, based on molecular forces, we can classify polymers into how many parts? Four parts here. One, two, here you have the third type, and here you have the fourth type. Let's see their difference, okay? The first one is here elastomer you have. Elastomers are those polymers with weakest intermolecular force. A best example, rubber, bone is, you'll have. What about here now? The next classification, fibers. Fibers are those polymers with having strong intermolecular forces. Those fibers or examples of polymers with having a strong intermolecular force includes nylon, polyester, trilene. Next, here you have again thermoplastic and thermosetting, okay? What their basic difference? Here, thermoplastic can be remolded by heating and cooling, whereas thermoplastic cannot be reused. That's the basic difference. Thermoplastic, they might be molded and reused, but this thermosetting is not further used. What are examples of this thermosetting? Polyethylene, PVC. What about this thermosetting? Bakelite, urea, and formaldehyde. Now here are some examples of natural polymer. Wood, leather, cotton, rubber, wool, asphalt are considered to be as natural polymers. Here are also examples of manufactured polymers. It includes here epoxy, which is not thermoplastic, which is thermosetting. Polyester, thermoplastic or thermoset. Sulfur concrete, which is thermoplastic. Methyl methacrylate, which is abbreviated as MMA, again an examples of manufactured polymer. Polyurethane is again considered to be as manufactured polymer. Next, polystyrene, which is thermoplastic. Polyvinyl chloride or PVC, which is again thermoplastic. Polyethylene, again thermoplastic, is considered to be as manufactured type of polymers. Here are activity for you student. The first one here, what it says, define each of the following term. Here you have the term monomer, polymer, homopolymer, copolymer, natural polymer, and synthetic polymer. I think you are capable how to define. The second activity here, it says classify the following polymer as natural or synthetic. Thanks for your attention. Thank you.